This is mathheals.com, where you can find more links to YouTube math videos and computer science. Let's take a look at an introduction to problem solving. And let's take a look at our first problem. You're going to find that word problems, some of them have a specific method of solving it, but a lot of them, each one's kind of different, which is why people struggle with word problems. This is a percent problem. I guess I better have my calculator up. Excuse me. Now, percent problems are simple, relatively. I'll show this just so we get this up. There we go. There's some key words that go along with your basic percent problems. The word is your equals, and the of is times. Now that's just not percent problems, that's any word problem. Usually the word is an equals, and then if you see of, then that means times. So this says 110% times 200. Now over on this side of the equals it says what? Well, that's our variable, that's x. Now we always want to put our percent in decimal form before we do it in the calculation. So to move it to decimal form, you move the decimal point 2 places to the left. This would become 1.1 times 200. If I were to put a decimal point on the 110%, it would have been right there. So 2 places to the left would be 1.1. 1.1 times 200 gives us 220. And that's our answer. And I don't know if I need to save these or not. Let me go look real quick. I don't think I do. Okay, yeah, the PDF page is already out there. So I just get the word problems and that's it. So, okay, this one is 30 is 70% of what? Now remember what the word is does. That's your equals. And this is 30 on this side of the equals. And the of is your times. So this says 70% times something. What? Well, that's our variable. Well, again, we want to change this to decimal form. That'd be 0.7 or 0.70. If you're put a decimal point here, it'd be right after the 0. Move it 2 places to the left, it'd be 0.7 or 0.70. Sometimes I put the 0 there to really emphasize what happens with a decimal point, but usually 0.7 is better. Now, we want to solve for x. We just go through our steps for linear equation that we went over before. First step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with an x on one side, numbers on the other. That's done. Last step, divide both sides by the number in front of your x. So we're going to divide both sides by 0.7. Trailing zeros drop off. Those 0.7s cancel. And we got 30 divided by 0.7. So 30 divided by 0.7. And it doesn't say how many decimal places, so I'll take it to 2. 42.86. And that's our answer. Let's take a look at this one. It says 50 is what percent of 400? Well, where the is our equals. So equals goes there. 50 is on this side of the equals, because this is before the is. Of is our multiplication, so we got what percent? That'll be our x, times 400. Well, now we want to solve for x. This is 50 equals 400x. First step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with an x on one side, numbers on the other side. That's done. Step 4, divide both sides by the number in front of your x. Number in front of your x is 400, so divide both sides by 400. I apologize. I just woke up and my throat's kind of still asleep. Okay, that gives us 0.125. Now it asks us, though, what percent? This is in decimal form. We want to move our decimal point 2 places to the right to put it in the percent form. So this would be 12.5%. And that's our answer. Okay, let's look at number 4. It says translate each of the following English statements in a math statement, then solve it. The sum of three times y and 5 is 26. Well, we talked about what the is before. That's your equals. So equals goes there, 26. The sum of 3 times y and 5. Well, here's the word sum. Usually there's a connector that goes with some words, like the sum of 3 and 5, the sum of 7 and 2. So the word and is our connector, and that's where our plus would go. So this comes down here. That's our plus. And then 5 follows that, so that's 5. Now before it, we got 3 times y. Well, that'd be 3y. So look for these words. Some words have connectors go with them. The difference of this and this. The product this of this and this. See, 5 or, well, that one actually is a connector. Like 5 divided by 1. Now in this one, first step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with a y on one side, numbers on the other side. So I take the 5 to the right side. When you take anything across the equals, the sign changes, so the 5 becomes a -5. Combine together like terms. Combine together numbers at any step. 26 minus 5 is 21. Last step, divide both sides by the number in front of your y, which is 3. These 3's would cancel. And 21 divided by 3 is 7. Okay. Number 5. Pattie's thinking of two numbers. She says that one of the numbers is 5 more than the other number. And the sum of the numbers is 65. What are the numbers? Well, we got our first number. And we got our second number. 5 more than the other number, and the sum of the numbers is 65. Do we know the first number? We don't, do we? So that's x. Now it says, she says one of the numbers is 5 more than the other number. Pretend that this is like 20. It's not, but pretend it's 20. 5 more than the other number. Well, that'd mean this would be 5 more, which would be 20 plus 5, or 25. Now think what you did here. We added 5, didn't we? So we took the 20 here and we added 5 to it. Well, same thing here. We take the x and we add 5 to it. Now, sometimes it's helpful for you to do a simple number example over here, and it's not actually part of the problem, but it helps you with the setup on it. Sometimes when we're dealing with just straight numbers, we can think along those lines real good. But when you start throwing X's and Y's and so forth in there, it throws us off. Okay, so that's our first number. That's our second number. It says the sum of them is 65. So this one plus this one, x plus 5, is equal to 65. And now we're just going to solve it with our steps. This linear equation. Combine together like terms in a step. X plus x is 2x. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on one side, numbers on the other. So I'll take 5 over. You take any number across your equals, the sign changes. So it becomes a -5. Combine together numbers at any step. 65 minus 5 is 60. Last step, divide both sides by the number in front of your x. So divide both sides by 2. And we get x is equal to 30. Those 2's cancel. Okay, so that means our first number is 30. Remember, these have nothing to do with it. And if this is 5 more, this will be 35. Okay, let's look at this one. Yeah, let's start a new page. I'm not sure if I have room here. It says the sum of 4 consecutive odd integers is 32. Find the integers. So we got our first odd. We got our second odd. Third odd. And fourth odd. Now, consecutive odd integers. That would mean, let me do a simple number example. 1, 3, 5, 7, for example. Now, these are numbers I made up. They have nothing to do with the problem. They help me to think through this. We don't know our first odd? No, that's x. Okay, now look over your number example here. The consecutive odd integers. Think, what did you do to go from 1 to 3? Well, we added 2. So to go from here to here, we're going to add 2. Well, to go from the 1 to the 5, think what you did. You added 4. So to go from here to here, you're going to add 4. And to go from the 1 to the 7, we added 6. So to go from the x to this one, we're going to add 6. Do you see how it's exactly the same pattern as you did with the simple number example as what you do with the x's? Okay, and it says the sum of these is 32, so all these added together, x plus 2 plus x plus 4 plus x plus 6 is equal to 32. Well, combine together like terms at any step. There's 4 x's here. 2 plus 4 is 6, plus 6 is 12. Equals 32. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on one side, numbers on the other. So I take 12 over, becomes a -12. You take anything across your equals, your sign changes. Combine together numbers at any step. 32 minus 12 gives us 20. Last step, divide both sides by the number in front of your x. So we're going to divide both sides by 4. Those 4's cancel. And we get x is equal to 5. So this first one is actually 5, which means this is these consecutive odd integers. So that's to be 7, 9, and 11. And those would be our answers. Let's see. Going to the final exam, which counts as 3 grades. Mark has test scores of 90, 85, 60, and 50. What score does Mark need on the final exam in order to have an average of 75? Well, think what average means. That means you That'd be good. If I'm trying to find the average of these three numbers, what I do is I add them together and I divide by how many I have. I had three numbers, so I divide by 3. So that'd be 12 divided by 3, which would give us 4. And this is our average. Okay, well, they got us some scores. We got 90 plus 85 plus 60 plus 50. And it says the final exam counts as 3 grades. So we're going to have x plus x plus x. Counts as 3 grades. What score does Mark need on the final exam in order to have an average of 75? Remember, average, you take your sum and you divide by how many there are. 1, 2, 3, 4, 5, 6, 7. So divide by 7. Well, now we're going to go through our steps. Combine together like terms in any step. X plus x plus x is 3x. 90 plus 85 plus 60 plus 50 gives us 285. So that's plus 285 over 7 equals 75. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. I do have a fraction. Multiply everything by the LCM of all your denominators. I only have one denominator, the 7, so that is our LCM. So I'll multiply both sides by 7. Here these 7s would cancel. And we got 3x plus 285 equals... Let me do it over in the calculator. It's too early. 525. Okay. Third step. Get everything with an x on one side, numbers on the other. So I take 285 over. You take anything across your equals, your sign changes. So it becomes a negative 285. I think that's 240. Yeah, 240. Okay. Last step, divide both sides by a number in front of your x. So we'll divide both sides by 3. And we get x is equal to 80. So the question was probably what score does Mark need to get in the final to have an average of 75? Well, he needs 80. And let me start a new page. And let's look at the next one here. It says Judy and Linda agree to share the cost of a $6 pizza based on how much each ate. If Judy ate 1/5 the amount that Linda ate, how much should each pay? Judy, Linda. Oftentimes, a problem puts one in reference to the other. And that's pretty vague, isn't it? Puts one in reference to the other, but it has to be that vague because each problem is different. It says here if Judy ate 1/5 of the amount that Linda ate, so Judy's amount that she ate is being put in reference to Linda. So Judy is being put in reference to Linda. Well, the one that's being put in reference to is your x. So that'd be your x. Now it says Judy ate 1/5 of the amount that Linda ate. So 1/5 of this would be 1/5 x. Now this one I would have had trouble putting numbers to it. It's easier just probably just to do the setup like you see here. And it says total it costs $6. So we got 1/5 x plus x is equal to 6. Technically these are like terms, but we'll find it easier to go through our steps first. First step is get rid of parentheses. Don't have any. Second step, get rid of fractions. Well, we have one fraction. Multiply everything by the LCM of all your denominators. I only have one denominator, so that's our LCM. So multiply everything by 5. So multiply it times the 1/5 x times the x and times the 6. Well, those 5's cancel. We got 1x or x plus 5x is equal to 30. Now you notice now it's real easy to combine together like terms. So if you got fractions, get rid of the fractions first, then combine together like terms. X plus 5x is 6x equals 30. Divide both sides by 6. And we get x is equal to 5. Now x is Linda, so this would be 5, and if it adds up to $6 total, this would be 1. How much should each pay? Yeah, they're asking for both of those. Number 9. It says in the state of Texas there's a sales tax of 3.11% on all goods purchased. If Megan buys 4 compact discs for $45.12, what will be the final bill? Rounded 2 decimal places if necessary, including sales tax. Well, the total, and this is one form. Your total is the amount plus amount times percent. Now the other type that we'll talk about is where you subtract it. Well, this is where you add it, and it's always of this form. You just put different variables in here, or if you subtract it like you're discounting something. Well, they're asking us what will be the final bill. So I just say B for bill. And then buys 4, so our cost, the price, let's say price. So P for amount plus P times, and then we're going to multiply it times our tax rate. So times our tax rate. Actually, let me just quit being lazy and just actually write those out. There we go. So final bill, and then I'll put the letters in there, is going to equal to our price plus our price times our tax rate. And this is when you go to the store, this is the formula. Okay, final bill, I would say B for bill. Price is $45.12 plus $45.12 times tax rate, and tax rate was 3.11%. Never do we work with it in percent form. We immediately want to change it to decimal form. So the 3.11% becomes 0.0311. There's not a whole lot of solving doing this one. It's already in the right form. 45.12 plus 45.12 times 0.0311. And I'll take it 2 decimal places. That'll give us 46 plus 0.52 for amount. Assuming I typed in right. Yeah. I think we'll see the other type where it's a discount type of deal. If not this section, then probably another one. Okay, number 10. It says, suppose that the price of a new Intermediate Algebra book is $110. Bookstore has a policy of marking text up 25%. What is the cost of the text to the bookstore? So we're going up. Okay. So again, we've got our total is equal to our amount plus our amount times the percent. Price is this, cost, what is the cost? Okay, so we got price, the student pays, is equal to the cost the bookstore buys it for, plus cost times markup percent. And it says the price of the Intermediate Algebra book is $110. Now cost is what they're wanting us to find, so that's a variable. I'll put C there. Then this will be C times markup percent, which is 25%. Again, we do not want percents. We immediately want to change them to decimal form for purposes of calculation. So this would be 0.25C. We move our decimal place 2 places left to change it to decimal form. Now this one's not too hard to combine together. They're like terms. There's the invisible 1 here, so 1 plus 0.25 gives us 1.25C. Now to solve for C, all we have to do here is divide by 1.25. Do that, those 1.25s cancel. And we got 110 divided by 1.25. And we get 88. So the cost the bookstore is paying, they're paying $88 for it, marking it up 25%, and that gives the student a $110 bill. Now this is something that actually, depending upon what area you go into, you may end up doing this in your day-to-day work. This type of problem. Some people say, "Oh, I'll never use this stuff." I worked at a motel for 8 months when my wife lost her job, and how we'd do it is people would come in. We had a computer program where it figured all for us, but we'd have people come in for a room. And let's say the room cost $70. It wasn't like a real run-down motel or anything either. So if it's real run-down, you might understand why we didn't do it on a computer. But the computer's kind of slow. So we checked people in by hand. We had this little adding machine had a tax button on it. And you put the $70 in there, push the sales tax, and it would tell you how much to charge a credit card. Well, sometimes what people would do is they would forget to push the tax button, or maybe they'd even forget to put it in the calculator. I don't know. And they would charge the room to the credit card at $70. Well, later on, we were supposed to go in and put it into the computer. They'd go in later and put it in the computer, and the computer didn't want the final amount. It wanted the beginning amount. It wanted this initial cost right here, and so they would sit there and guess because they knew they're trying to find this cost. And well, the tax rate I think back then was 14.1% for motels. They knew they wanted to end up with $70. So what they do in a computer program is they type in 60. See if it gave them 70. If it didn't, they backed it out. They'd try 65. They'd sit there and guess. I'd come in because I did night audit, third shift, and they'd have tried like 20, 25 times. Well, it's the same formula you see right here in trying to figure out how to do it. You combine together like terms. This is an invisible 1 here. This would be 1.141C is equal to 70. And then you take 70 divided by 1.141. And whatever that gives you, when you plug in your calculator, would be the amount you need to put in a computer program. Now, you're sitting there, well, why didn't they just put in a computer program in the first place? It probably calculates tax and does everything. Yeah, it does. But the problem with it is the computer system was a little bit slow. So to check somebody in, it may take 15 minutes going through the different computer screens. Maybe a little bit less. But imagine a motel. And this isn't like the Marriott where you know you're going to wait an hour to get checked in type of deal. But this is a motel where there's other ones around it. It is about $70 a night. So they expect a little bit of service. They go there. There's 2 people in front of them. And it takes 15 minutes to do each person. Now it's 30 minutes they had to wait. Most people don't want to wait 30 minutes. Most people won't wait 30 minutes. If there's other motels around, they'll get disgusted and just leave. So the owner of the motel did not want us to use the computer to check people in. She wanted us to do it over on the side, and then when it was slow, then we'd go and do our paperwork on the computer. So sometimes, it seems like, well, I'll never do this. We have computer programs and so forth. You might be surprised. This was a routine issue because people would forget to push that tax button, or the power would go out and that tax button would get screwed up, and then have to do things by hand. I don't think I got room for the next one. It's interesting working at that motel. Easy work. Night audit. I had about an hour's worth of work every night, and then I ate free food and watched TV the rest of the night. Tried to stay awake. A lot of weird people going to motels, though. Jack and Diane have $40,000 to invest. Their financial advisor recommends they diversify by placing some of the money in stocks and some in bonds. Based upon current stocks and bonds. Let me write that down. Based upon current market conditions, he has recommended the amount of bonds should equal 1/3 of the amount invested in stocks. How much should be invested in stocks? The amount in bonds should equal 1/3 of the amount invested in stocks. So bonds is being put in reference to stocks. Bonds is being put in reference to stocks. The one it's being put in reference to is always your X. He has recommended the amount of bonds should equal 1/3 of the amount in stocks. So if this is X, this is 1/3 X. And total they have 40,000. So this plus this should give us 40,000. So X plus 1/3 X is equal to 40,000. Now these are like terms, but again, not so easy to combine together. Let's first go through and get rid of fractions, and then we'll combine together like terms. Well, first step is get rid of parentheses. Don't have any. Second step is get rid of fractions. We do have a fraction. Multiply everything by the LCM of all your denominators. Only have one denominator, the 3, so multiply everything by 3. So 3 times x, 3 times 1/3 x, and 3 times 40,000. So that gives us 3x. Here the 3's cancel. We got 1x, or x, is equal to 120,000. Now combining the like terms at any step. 3x plus x is 4x, equals 120,000. Last step, divide both sides by the number in front of your x. So we'll divide both sides by 4. And those 4's would cancel. And we get x is equal to 30,000. Well, x is stocks, so we'll put 30,000 in stocks. And if total adds up to 40,000, then this has to be 10,000. Those would be our amounts. Number 12. Patrick is a loan officer at a bank. He has $1 million to lend out and has 2 loan programs. His home equity loan is currently priced at 5% per annum. I'm saying that right. While his unsecured personal loan is priced at 15%. Bank president wants Patrick to earn a rate of return of 10% on the $1 million available. How much should Patrick lend out at 5%? This is kind of a mixture problem. And these are set up such that you got 2 quantities. In this case, we'll have dollars and we'll have percent. And we'll have dollars and we'll have percent. And we'll have dollars and percent. Might not have made those big enough, but we'll go with them. Okay. 1 million lend out and has 2 loan programs. His home equity loan is currently priced. This one's home equity. is currently priced at 5%. So this would be 5%. The unsecured personal loan, not that you can read that, but personal loan is 15%. The bank president wants Patrick to earn a rate of return of 10%. So we want the interest over here, the rate of return, to be 10% on 1 million available. So this will be 1 million. Okay. How much is in home equity? Well, actually, what's it asking for? How much should Patrick lend out at 5%? 5% is this one. So, okay, how much is in home equity? We don't know. That's X. Now, pretend that it's 200,000. Think what would be in here. We have 1 million total. This is 200,000. Well, if I took 1 million minus the 200,000, that would give us 800. Should have put commas there so I could see it a little bit better. If you took the 1 million minus 200,000, then that'd be 800,000. So if this is 200,000, this would be 800,000. They would add up to 1 million. Well, we don't know this is 200,000. I'm just putting a number there just so we have to see something. So here we have 1 million minus 200,000. It's really X. So this is going to be 1 million. $1 million minus X. So that's our setup. Now these numbers have nothing to do with it. They help me to think how this should be set up. Well, again, I don't want percent. I want them in decimal. So this will be 0.05x. And this one will be 0.15 times 1 million minus x. And this one will be 10% times 1 million. Well, first step, get rid of parentheses. 0.15 times 1 million. Let's see if I can add 0, 0. Yeah. Gives us 150,000. 0.15 times negative x is negative 0.15x. And I shouldn't have to plug this one in, but I'm not very good at decimals. 0.1 times, I think it's 100,000, but let's see. 100,000. Okay, combine together like terms at any step. Here we have 0.05x minus 0.15x. That gives us negative 0.10x plus 150,000 equals 100,000. Now we got rid of parentheses. Second step is get rid of fractions. Don't have any. Third step is get everything with an x on one side, numbers on the other side. So I'll take the 150,000 over to the right side. Anytime you take anything over the other side, the sign changes. I'm messing up these numbers. I hate having so many zeros. 100,000. We'll have to put commas there. Minus 150,000. So negative 0.10x equals 50,000. Negative 50,000. Last step, divide both sides by number in front of your x. So we'll divide both sides by negative 0.10. And let's see what we get. Negative 50,000 divided by negative 0.1. That gives us 500,000. Now, assuming I didn't mess up on my basic math, that'd be how much we want to put in our home equity loan. Let me double check myself on that. Because I do stink at decimals. Where would that be? Probably number 3. Nope, I lie. Doesn't look like I'm. Oh, I was just scratching those out because of that. Yeah, 500,000. Now, they only want them out at 5%. So, okay, let's look at another mixture problem. That's mixing money together, mixing one account with another account to get your interest or your total. Number 13. Sweet Tooth Candy Store sells chocolate-covered almonds for $7 per pound and chocolate-covered peanuts for $8 per pound. Manager decides to make a bridge mix that combines the almonds with the peanuts. Almonds plus peanuts equals bridge mix. We'll have two quantities in each one of these. One quantity is too easy. One quantity is like you got 3 gallons of water and you need 5 gallons of water. How many gallons of water do you add to it? Way too easy. Three quantities are way too hard. Okay. Candy store sells chocolate-covered almonds for $7 per pound. And, okay, so it looks like dollars and pounds. I think that's LB. Okay, almonds are $7 per pound. Chocolate-covered peanuts for $8 per pound. That's $8. Combines and decides to make a bridge mix. She wants a bridge mix to sell for $7.40 per pound. So that's $7.40 per pound. There should be no loss on revenue from selling a bridge mix versus the almonds and peanuts alone. How many pounds? Now, what they're saying there is that mixing it together, doesn't make a difference. How many pounds of chocolate-covered almonds and chocolate-covered peanuts are required to create 50 pounds of bridge mix? So they're telling us there's 50 pounds of bridge mix. We don't know how many almonds there are. Let's say this is X. Now let's pretend the numbers here. Let's put 10 here. Well, if there's 10 pounds here and there's 50 total, how much goes here? Well, we take 50 minus 10, and that would tell us there's 40 pounds that goes here. Now, there really isn't 10 in this first one. I just put it here to wrap my mind around around how to set up. We really have X. So where I have 50 minus 10, I'm going to have 50 minus X. Now, again, these help you with the setup. They're not using the problem at all. Well, 7 times X is 7X. We're getting rid of parentheses here. 8 times 50 is 400. 8 times negative X is negative 8X. And 7.4 times 50 gives us 370. Well, combined to get like terms in any step. 7x minus 8x is negative 1x or negative x. Plus 400 equals 370. Get everything with an x on one side, numbers on the other. So take negative x over, take 370 over. You take anything across your equals, your sign changes. So this becomes a negative 370. Negative x becomes a positive x. Well, 400 minus 370 gives us 30. So we got x is equal to 30. So that means we're going to want 30 pounds of almonds. And if there's 50 total, then there's 20 pounds of peanuts. And those will be our answers. Let's take a look at this one. It says Diana has been saving quarters and dimes. She opened up her piggy bank and determined it contained 60 coins worth $7.50. Determine how many quarters and dimes were in the piggy bank. So we've got quarters plus dimes equals our total. Now sometimes, and this is an example of them, we'll have two quantities over here, but then they'll give us a grand total over here. Like, see, they tell us it's worth $7.50. So total amount in the piggy bank is $7.50. Well, quarters and dimes says how many. So we're going to have just how many, and then dollars. And quantity in dollars. Quarter's worth 25 cents, so it's 0.25. Dime is 10 cents, so it's 0.10. We don't know how many quarters there are, so that's X. It tells us there's 60 coins. Well, if there's 60 total, let's pretend there's a number here. Let's say there's 20 quarters. How many dimes would we have if there's 60 coins total? Well, we'd have 60 minus 20, or we'd have 40. Well, we don't really know this is 20. This is actually X. So instead of having a 20 here, I'm going to have an X. So I'll have 60 minus X. Again, these numbers just help us with the setup. So I got 0.25X. And, oh, I hate decimals. 0.10 times 60, I think it's 6. Shouldn't have to think this hard this early in the morning. 60 times 0.1, there. And then 0.10 times negative x gives us negative 0.1x. And over on the right side, 7.50 just becomes 7.5. You drop off the zeros at the end of decimals. Now combine together like terms. We got 0.25x minus 0.1x. And I hate decimals. 0.25 minus 0.1. 0.15. So combine together those like terms, we get 0.15x plus 6 equals 7.5. Get everything with an x on one side, numbers on the other. So I'll take 6 over. We'll get 0.15x is equal to 7.5 minus 6. 7.5 minus 6 is 1.5. Divide both sides by a number in front of your x, which is 0.15. And 1.5 divided by 0.15 gives us 10. Well, that's x is the number of quarters, so that means there's 10 quarters. Total of 60 coins total, that means there's 50 dimes. Now there is if you hate decimals as much as me, there is a shortcut to this. I don't usually shortcuts, so I didn't mention it, but if this has 2 decimal places, this one has 2, and this one has 2. This would automatically become 25x plus 10 times 60 minus x equals 750. You can multiply everything by 100, and that moves the decimal place. Now notice, if I move it here, I don't want to move it in the 60 minus x. You can only move it in one of these products. I'll tend to skip over that though, because again, I don't like to show shortcuts. Students click better, I think, if you don't go through all the different shortcuts. No, there's no think about it. In 17 years' time, I've noticed that. 2 cyclists leave a city at the same time, one going east and another going west. So here we have a cyclist going this way, and here we have a cyclist going that way. The westbound cyclist travels at 5 miles per hour faster than eastbound. Well, if the eastbound's going R for rate, 5 miles an hour faster, this would be R plus 5. If after 4 hours, t is equal to 4, they are 60 miles apart. So the distance that they get apart will be 60. It says how fast is each cyclist riding. This is based upon the formula. Distance is equal to rate times time. So they're working together to achieve this distance. So we're going to have the rate times the time of the westbound plus the rate times the time of the eastbound. And that's going to give us our total. Well, the rate of the westbound was r plus 5 times time, which was, they told us, was 4 hours, plus this is r times time, which again they told us was 4, equals our grand total, which was 60 miles apart. Okay, 4 times r is 4r, 4 times 5 is 20, 4 times r is 4r, equals 60. 4r plus 4r is 8r, plus 20 equals 60. Takes 20 over, becomes a negative 20. And 60 minus 20 gives us 40, and then divide both sides by 8. And we get r is equal to 5. So what are they asking? How fast is each one going? This one is going 5 miles per hour. This one's going 10 miles per hour. And that would be our end of that section.